So hello everyone. So today we are going to discuss about the properties of colloids. So far we have covered the types of colloids, what are these colloids, what are the basics of these colloids. Today we'll be discussing about the properties of colloids and the most important theory about the stability of colloids, that is the DLBO theory, and maybe some extra points regarding where your direct questions can be asked from your GPAT point of view. So the properties of colloids here we can see are divided as the optical properties of colloids, the kinetic properties of colloids, the electrical properties of colloid. So all these properties of colloids, other than these, actually these are really important. Other than this, there are few other properties which are based on the physical nature, the physical properties, the heterogeneity of the colloidal molecules. So I am going to discuss a little about them in brief. So you have to see that these optical properties, these kinetic properties, these electrical properties, all these properties are really important to see. All of them carry an equal chance of coming in your exam. The equations it says, the basic it covers, right? So one by one I'll be discussing. So before that I am going to tell you a little about the first property before the optical property, that is the physical properties. As I've mentioned about the colloidal particles, because colloidal particles, although they tend to appear homogeneous, but they are actually heterogeneous in nature. So the physical property out of the first is the heterogeneity, of course. Okay, so heterogeneity, why? Because it actually consists of two phases, as I've mentioned. One is the dispersed phase and other one is the dispersion medium. Alright, now the visibility of the particles, because these particles actually appear homogeneous, they appear homogeneous although they are actually heterogeneous. These are not visible to the naked eye. Please remember, these are not visible to the naked eye. These are some basic, you can say, physical properties that the colloidal particles actually bear with them. Other than the optical properties, the kinetic properties that we are going to talk about in today's session. So moving on, these were the basic physical properties based on the nature of the colloidal molecules. As I've mentioned, the important major topics to cover is the optical properties, which includes the Faraday-Tyndall effect, the electron microscopy, the light scattering phenomena, the kinetic properties, which include the Brownian motion, the diffusion, the osmotic pressure, the sedimentation, the viscosity, and followed by the electrical properties of the colloids. So firstly, moving to the optical properties of colloid, which includes the Faraday-Tyndall effect, you must see that, you can already see with the diagram that the light scattering in the colloidal particle, which is the so-called scattering of light, the Tyndall phenomena, is very much clear in case of the colloidal particles. However, you must know that whenever a beam of light is passed through this solution, this colloidal solution, some of the light maybe get absorbed, some of the light maybe gets transmitted, while other gets scattered through it. Alright, so you can see here in the colloidal system, colloidal solution, the light beam is clearly visible because of the colloidal particles. So colloidal particles, actually in this case the beam is visible because some of light, as I've mentioned, can be absorbed, some of light is scattered, while some of light is actually transmitted through the sample. So next thing is that the colloidal solution actually appear turbid due to the scattering of light by the colloidal particles, and this effect is known as the Faraday-Tyndall effect. Yet again I am going to repeat, you can see it very clearly in the image as well. that the colloidal solution appears actually turbid because the light is actually scattered by the colloidal particles, and this effect is known as the Faraday-Tyndall effect. This comes under your optical properties, right? Very much clear with the image part. Okay students, now moving on to our next property, that is your kinetic properties. Very important from an exam point of view. So in kinetic properties, what we are going to discuss, we are going to discuss about the Brownian motion, we are going to discuss about the kinetic energy, we are kinetic properties including the diffusion also, the osmotic pressure also, these are all the sedimentation also, these are all considered under the kinetic properties of the colloidal particles. So first is the Brownian motion. As known, the Brownian motion is nothing but the zigzag motion of the particles. Here is also written, it is the zigzag motion of the particles. You can see here the zigzag motion of the particles. Now colloidal particles are actually subjected to the random collisions with the particles of your dispersion medium. Hence such the colloidal particles actually pursue an irregular or a complicated zigzag path, as you can see in the image. So Brownian motion describes the zigzag motion of the particles. As we can see, the particles that actually known to collide with the particles of the dispersion medium, or they can collide with the wall, with the other particles, which actually change their direction and their velocity. So particles are known to move against the gravitational forces. The Brownian motion stops when there is increase in the size and the viscosity. Very important point, because the kinetic energy is required whenever the particle is in motion. So if the size is going to increase, the movement is going to restrict. Okay students, so very easy, the velocity of the particles tend to decrease with the increase in the size and the increase in the viscosity of the medium. So this is the Brownian motion, which is among the kinetic properties of the colloidal particles. Next kinetic property is the diffusion. We have already seen what does this diffusion includes, that whenever the particles tend to move from a region of their higher concentration to a region of their lower concentration until the equilibrium is maintained, right? So you can see in the image as well, the particles are actually diffusing from their higher concentration to more of a lower concentration. Sorry. Now this actually happens until the diffusion equilibrium is attained. The particles tends to move from the higher concentrations to a lower concentration. This is explained by the Fick's law. Directly the question can be asked, the Fick's law explains what? It gives the expression for the diffusion coefficient. So it states that the particles diffuse spontaneously from a region of higher concentration to a region of lower concentration until the diffusion equilibrium is attained. So now I am here writing the expression of the Fick's law, which states which is the dm upon dt is equal to minus dA dc upon dx. Very important expression. Now this dm is actually the mass of substance that is diffusing across the area, that is A. This is the mass of substance diffusing with the time dt under the influence of the concentration gradient, which is dc upon dx. I am just writing it here. Okay students, and D is what? D is the diffusion coefficient. Now other than this, you must know that with the decrease in the particle size, very important point, with the decrease in the particle size, the velocity of the molecules is going to increase, and vice versa. When there is increase in the particle size, then the velocity of the particle, velocity of the molecules is going to decrease. So the first point that we know, that with decrease in the particle size, the velocity is going to increase. Secondly, with the increase in the temperature, the velocity is going to increase, because the particle tend to come in the state of motion with the increase in temperature. Third, with the increase in the viscosity, the velocity of the molecules tends to reduce. So you must know these three conclusions from the diffusion equation that I have mentioned. First, I have stated that with the decrease in the particle size, the velocity of the molecules is going to increase. Now, with the increase in temperature, because upon increasing the temperature, the particles tend to come in the motion, they are colliding with each other. So with increase in temperature, the velocity is going to increase definitely. Now third is the viscosity. With the increase in the viscosity, the velocity is going to reduce. Alright, these are the three main rules of, you can say, diffusion, right? So we have covered the Brownian motion thing, we have covered the diffusion. These come under your kinetic properties of the colloids. Next is the sedimentation. So sedimentation, we have discussed about it in the micromeritics also. Sedimentation, you have already heard about it by now, and it is actually based on your Stokes law equation, which is as follows. Here V is actually the velocity of your sedimentation. I'll write it quickly. V is your velocity of sedimentation, okay, is equal to d square rho s minus rho 1 chi upon 18 eta. Now this V is the velocity of the sedimentation of spherical particle, which is having the diameter d, density rho as mentioned, and viscosity as eta. Obviously that is under the influence of your gravity. G is your acceleration due to gravity. For your exam point of view, I can say very much direct questions are asked, that which among the following is the optical property or the kinetic property of the colloids. To be very simplified, or your questions are asked based on directly out of your equations of your, you can say, the Stokes law can be asked, that it gives the expression for what? The velocity of the sedimentation. So direct such questions can be asked. Very simple, you can just see how these diffusion, the Brownian motion and the sedimentation are all just revolving around the properties of the colloids. Now other than this sedimentation, there is one more property. I'll just write it here. There is one more property that we are going to talk about, is the osmotic pressure. Yes, so one more property that we are going to talk about is the osmotic pressure. This all comes in your kinetic properties of the colloid. So osmotic pressure, this is yet another very important out of others as well, because direct questions can be asked based on the equation of the osmotic pressure as well. So you have heard about the osmosis already, that how in this also the movement takes place from a region of the higher concentration to a region of their low concentration. However, the difference is that it includes a semi-permeable membrane. We have known that semi-permeable membranes are which allows the entry and the exit of some substances, right? So they are actually based on the size, how the particles are able to pass through the semi-permeable membranes. So the pressure that is actually required to balance out the osmotic flow is termed as your osmotic pressure. Okay students, so the equation that can help you deduce the osmotic pressure is given as follows, which is pi. This is the osmotic pressure only, that is equal to CRT. Now this C is the molar concentration of the solute. R is the molar gas constant. So this equation is based on the fact of your osmotic pressure, which is the pressure, I am repeating it again, required to balance out the flow of basically when the particles are moving from their higher concentration to a region of their lower concentration, just like this, with a semi-permeable membrane. This is the region of suppose higher concentration, this is the region of lower concentration. So the movement of particle across this concentration gradient and the semi-permeable membrane, the pressure through which the particles tend to flow, this is known as the osmotic pressure. It is given by the equation as mentioned. So this, other than this, the other properties, the viscosity, and there are very much the electrokinetic properties, also the electrical properties. The electrical properties, if we talk about, this is not very much topic that we will discuss today, but yes, I am going to give you a little brief about why we need to study about the electrokinetic properties of the colloids, because colloidal particles can carry charges which could be either the positive one or could be the negative ones, right? So the positive charged colloidal particles might include the dispersions which contain the, you can say, metal oxides, for example, and the negatively charged colloidal particles includes the colloidal dispersions of the sulfur, or you can say that even the proteins are the charged molecule, right? So the electrical properties of the colloidal particles, these phenomena are observed in your electrical double layer, the electrophoresis, the electroosmosis, the streaming potential, and the sedimentation potential. However, as mentioned, these topics I will not be discussing here because they are not very much a part of your syllabus. You just need to, if you are very much aware of this properties that I have just shown you here, you must know about the physical properties. What are the physical properties? The optical properties, very important, the Faraday-Tyndall effect. The kinetic properties that we have discussed includes the Brownian motion, the diffusion, the osmotic pressure, the sedimentation, and the viscosity. Now, moving on to the very important other topic that we are going to talk about is yet another important topic for today's session is the DLVO theory. After that, I am going to just define a little bit of few terms on which direct questions can be asked. We are going to discuss that, but before that, very important topic not to miss out on is your DLV theory. Very important theory which actually explains a lot about the stability of the colloids, how the attractive and the repulsive forces come into play, how the aggregates are made, and how the floccules are formed. So you should have an idea of the DLVO theory, which is actually based on the name of its scientist. As just mentioned above, you can see the name of the scientist that has been listed here, and of course this diagram, which is a potential energy curve, that is we are going to discuss today. But before that, you should know that this theory is based on a very simple phenomena, that is the particle-particle interaction. Okay students, particle-particle interaction. Now these interactions can accommodate two types of forces, you can say. One is your attractive forces and other one is your repulsive forces. Just like you might know about the like charges repel each other, right? And so these have, suppose this shows the repulsion in between the particles, and if the particles are unlike particles, the charges are different, so these show that the particles are attracted towards each other. Alright, so this is based on this type of particle-particle interaction. Yes, so using this theory, which actually combines your van der Waals forces of attraction and the electrical double layer theory, we can actually study how the behavior of the colloidal particle is affected, how the stability phenomena can be explained. So because we have seen that in case of the colloidal particles tend to be in a randomized motion, or in the Brownian motion to be specific, due to which the particles tend to collide with each other. So during such collisions, what happens, such particle interaction occurs, which might include the repulsion and which might include the attraction between the molecules. So when the repulsion, what happens when the repulsion is more? So when the repulsion is more, the particles tend to rebound after collision and they remain individually dispersed, right? So I'll repeat this again. So if there is a repulsion between the particles, what happens is, then when the repulsion is more, the particles tend to rebound to their original state after the collision and they remain individually dispersed. But in case of attractive forces, what happens is the particles tend to adhere onto each other after collision, which might lead to the formation of the aggregates. So such kind of attractive forces actually promote the aggregation of the colloidal particles. So these are some basic concepts on which your DLVO theory is based on. As mentioned, the particle-particle interaction, it's all about the attractive forces, van der Waals attractive forces and the repulsive forces. So now, as in the diagram also, I'll just make the curve here again. We can see this is a potential energy curve. Here the energy is positive, here it is negative. This with what energy? This is the potential energy, the energy of interaction. Okay students, now this theory gives out a plot like this. So this segment right here, this point right here indicates the primary minimum. And this point indicates the primary maximum. We are going to see what the significance of these points hold. And this is going to be your secondary minimum. Okay students, so you should understand that in case of this primary minimum, this is actually the region of high attractive forces. This is actually the region of high attractive forces. We have seen that such attractive forces can cause the particles to aggregate, which can cause instability in your formulation. because the part ultimately what will happen, the particle size is going to increase because of the aggregation, and this will in turn cause the instability because the particles are so close that they will ultimately coagulate, and this will cause the aggregation and the instability. So this primary minimum indicates the high attractive forces between the particles. This primary maximum, on the other hand, actually indicates the region of high repulsion, because for the stability reasons we have seen with the attractive forces the instability comes because there are aggregates that are formed. So we need more of the repulsive forces to attain to the stability conditions of the colloidal particles. So the primary maximum is the region of maximum or high repulsion between the particles. Okay students, the third one is your secondary minimum. Now this region in particular, here although the attractive forces exist, but these attractive forces are not very strong, so the particles appear as floccules here, which can be redispersed on shaking. So here also you should understand the attractive forces, yes, the attractive forces exist, but these are not so strong so the particle just appear as floccules which can be redispersed on shaking. So this is the basic phenomena included in your DLVO theory. Now this DLVO theory is really important from your exam point of view. Basic generalized questions can be asked. You should have this basic understanding of the DLVO theory. Here in this plot also you can see the primary minimum portion, where the aggregates are formed. Here it is mentioned that in this region there is such irreversible aggregation between the colloidal particle that takes place. Here is the secondary minimum, where also the attractive forces exist, but the attractive forces are not very sufficient to cause the aggregation, but still they tend to form the floccules. And this is the region of your repulsion. The repulsive forces are high, so the particles now appear as separate individual particles in the dispersion medium. So this was all about your basic properties of the colloidal particles and the important DLVO theory also. So I think we have covered the most of the part of the colloids. In case any small of the portion is left, any important topics, any important points we'll be discussing in a separate video regarding the important terminologies. I'll be summarizing for the physical pharmacy. I'll be covering those there, and I hope you have understood the basic phenomena. You have covered the topics. This topic, however, is a very basic one, but the questions that are asked can be very much direct, relevant to the topic. So I suggest to have a basic understanding of each topic that you studied here. And all the best to you all. We'll see you in the next class. Thank you so much.